Hi everyone. Today we're going to be completing our notes on law of sines. Let's start with this warm-up, using what you know about trig functions, triangles, and whatever else you know to solve this triangle. Just as a reminder from geometry, solving a triangle means find all those missing side lengths and angles. Okay, so here's your triangle ABC. Angle B is 70 degrees, angle C is 28 degrees, and side length AC measures 9 units. Okay, so go ahead and pause the video and try this for yourself. When you're ready to check your answers, go ahead and unpause. Okay, so probably one of the first things that you notice about this triangle is that we have two of those angles. If you remember back from geometry, we know that the interior angle sum for all triangles is going to be 180 degrees. Therefore, we can find the measure of angle A, to be equal to 180 minus the other two angles. So minus 70 and minus 28. Okay. If you subtract out the other two angles, we're going to find that the measure of angle A is 82 degrees. So that's one of the things that we can find out. Okay. If you made it here and couldn't find those other two side lengths, that's totally okay. That's what today's lesson is for. If you found something else, you can follow along with me and check and see if you got your answers correct. Okay, so one strategy that I've tried here is I know a lot about right triangles. I know right triangle trig. I know Pythagorean theorem, all of those things. So I'm going to go ahead and construct some right triangles. I'm going to drop an altitude from vertex A down to side length BC. Okay, drop a perpendicular there. We're going to call that side length H. Okay. The other two side lengths, the one across from angle C is going to be side length C, and the one across from angle A is going to be side length A. Okay. So looking at angle C, I notice that we have the opposite side of angle C. This is a right triangle here. So opposite of angle 28 is the height, h, and then the hypotenuse of this right triangle is 9. So if I have opposite and hypotenuse, I can set up a sine equation. So the sine of 28 is equal to the opposite over hypotenuse. Well, solving for h here, multiplying both sides by 9, we get h is equal to 9 times the sine of 28. Okay. I also notice that we can do the same thing on the other side. So we have the sine of 70, angle B, is equal to the opposite, again the height, over the hypotenuse, c. And that gives us another equation. We're going to solve for h here, is equal to c sine of 70. Okay. So then using these two equations, I know that we can set them equal to each other. So 9 sine of 28 must be equal to c sine of 70. Okay, because they're both equal to the height. Well, solving for c, dividing both sides by the sine of 70, we get c is equal to 9 sine of 28 over the sine of 70. And just out of curiosity, let's go ahead and find a decimal approximation for that. Open up your calculator and a new document. So we have, I'm going to hit Control Divide, get that fraction bar. So Control Divide, 9 sine of 28 over the sine of 70. And again, make sure you're in degrees mode. If you need to change, go ahead and click in the top right, and that's going to switch it from degrees and radians. The Inspire here gave me an exact answer, so we'll hit Control and Enter to get a decimal approximation. We get side length C is about 4.496 units. Okay, so that's another quantity that we can solve for. We get C is equal to 4.496. So all that's left is side length A. Well, I notice that we have side 9 and 4.496 and 82 here. We have side angle side. I can use that law of cosines to find that last side. So we have the side length across from angle A. We have A squared is equal to our 9 squared plus our 4.496 squared minus 2 times 9 times 4.496, and then cosine of 82. Okay? Let's go ahead and just plug this right into our calculator and see what we get for a squared. All right, so we get 9 squared, and then we have plus. I'm going to just use this answer here, so I'm going to hit Control and negative, and that's going to give us answer squared. And then we have minus 2 times 9 times answer. So that's our 4.496. And then cosine of 82. Okay. And let's see what we get. We get a decimal approximation of about 89.954. We're rounding. Okay. So a squared is equal to 89.954. Before I continue, one thing to note is you might have noticed that I keep using answer in my calculations in the Inspire. And the reason why is I don't want to round into the very end. So if there's an opportunity for me to use previous calculations directly into my inputs of my new calculations, use that. Don't round your answers until the very end. Otherwise, you might have some margin of error. Okay? Okay, so back to this. We're going to take the square root of both sides, and that's going to give us the side length A. So back here, I'm going to take, again, square root of answer, and that gives us 9.484. All right. So now we've solved the triangle. We found all the missing pieces here. And let's go ahead and label A as 9.484. If you had trouble with that, that's totally okay. We're about to discover an easier method for finding these quantities, and that's called the law of sines. Okay. I hope this hint was helpful. So dropping a perpendicular from one vertex to the opposite side forms two right triangles. We got all of that right triangle trig. So the law of sines here, let's actually talk about that right triangle trig. We can use right triangle trig. Okay. So we used in this example, we used the sine of C is equal to the height over side length B. Okay. We said side length, the sine of angle C is equal to the opposite over the hypotenuse, which is side length B. We also looked at angle B, and we said the sine of B is equal to the opposite, the height, over the hypotenuse, side length C. We solved for each of these for h and then set them equal to one another. So we got h is equal to b sine of c, and we got h is equal to c sine of b. Well, if we set these equal to each other, just like we did above, we have b sine of c equals c sine of b. If we divide both sides by b and divide both sides by c, then we get that the sine of c over side length c is equal to the sine of b over side length b. And notice that I didn't use any quantities in here. Unlike what we did above, we used our 9, we used our 28, we used our 70. Down here, I just used arbitrary values. And in fact, this is true for all triangles. So we have side lengths A, B, and C. In this case, we just looked at B and C and angles B and C. But this is true also for angles A. This relationship here, this proportion, or these equivalents of ratios, right, is true for all angles and side lengths. This is the law of sines here. The sine of an angle over the side length across from it, that ratio is going to be the same for any side length and angle, any corresponding side length and angle. Okay. This is really helpful when we have three cases. When we have angle, side, when we have angle, side, angle, or when we have side, side, angle. And note that that third case, the side, side, angle, is the ambiguous case, which we'll talk about in our next notes. So this first case, if we have angle, angle, side, that would be if I had like this angle up here, angle A, and this angle over here, angle B, and then the side length across from A, so side length A. If we had angle, side, angle, that would be if I had like angle A and angle B, and then the side length in between them, so side C. Or likewise, if we had side, side, angle, this would be if we had side length C, side length A, and then angle C. But note that this is the ambiguous case. Okay, which again, we'll talk about in our next notes. But just as a preview, it's called the ambiguous case because when we have this set of information, it's ambiguous whether we have 0 triangles, 1 triangle, or 2 possible triangles, right? This doesn't clearly define exactly one triangle. Yeah, it does not clearly define exactly one triangle. Okay, so let's get some practice. Law of sines. Using the law of sines, let's go ahead and find the missing side length or angle designated by x. Okay, so for number 1, we have triangle ABC. I notice that we have angle A and B, and we have side lengths A and B, whereas B is defined as x. Okay, so I'm going to go ahead and write out my law of sines. Sine of A over side length A is equal to sine of B over side length B. So sine of angle A is 50 degrees, over side length A, the side length across from it is 8, is equal to sine of B, which is 35 degrees, over side length B is x. Multiplying both sides by x and by 8, or in other words, cross-multiplying, we get x sine of 50 is equal to 8 sine of 35. And then solving for x, dividing both sides by sine of 50, we get x is equal to 8 sine of 35 all over sine of 50. Let's go ahead and plug that into our calculator. So we have x is equal to 8 sine of 35 over the sine of 50. Again, we're in degrees. This is the exact answer, so control enter. About 5.990. Okay? So x is equal to 5.990. All right. Number 2. In triangle DEF, D is 34 degrees, E is x degrees, DF is 7 units, and EF is 8 units. Let's go ahead and draw this triangle DEF. All right. So angle D is 34. Angle E is x. DF is 7 units, and EF is 8 units. Okay. So I noticed that we have the angles and side lengths across from them. So we have side angle here. Let's go ahead and plug this in. So we have the sine of 34. This is angle D over side length D is 8 is equal to the sine of x over 7. All right. So solving for x here, we have to cross multiply. So 7 sine of 34 is equal to 8 sine of x. Dividing both sides by 8, we get sine of x is equal to 7 sine of 34 all over 8. And then to get x by itself, we got to get it out of the sign. So we're going to use the inverse sign. So taking the inverse sign of both sides, the sine and inverse sign cancel each other out. We're just left with x. And then on the left-hand side, we have the inverse sign of 7 sine 34 all over 8. Let's go ahead and plug that into our calculator. So we have inverse sine of, 7 sine 34 all over 8. And control enter. We get about 29.294. X is equal to 29.294 degrees. All right. One more problem. A satellite orbiting the Earth passes directly overhead at observation stations in Phoenix and Los Angeles, 340 miles apart. At an instant when the satellite is between these two stations, its angle of elevation is simultaneously observed to be 60 degrees at Phoenix and 75 degrees at Los Angeles. How far is the satellite from Los Angeles? So looking at this diagram here, I'm looking at the question, how far is the satellite from Los Angeles? We're going to be solving for side length B. If the satellite is at point C and Los Angeles is point A, then the distance is point B. Okay. The side length C is 340 miles, so this is the distance from Los Angeles to Phoenix. I notice that we have, let's see. We have angle A, we have angle B, and we have side length C, and we're solving for side length B. So because we have side length C, I need to know angle C. I need that corresponding angle. Well, fortunately, we have the other two angles. We know that all angles in a triangle should add up to 180 degrees. So if I add up 75 and 60 and subtract that sum from 180, that's going to give me the measure of angle C. So 75 and 60 gives us 135. Subtracted from 180, we have 45. Okay, now we're ready to use the law of sines. So if we're trying to find side length B, we have the sine of the angle across from B, or 60, over side length B is equal to, using C and side length C, we have sine of 45 over 340. Okay? So we have cross multiplying, we have 340 sine of 60 is equal to B sine of 45. Okay. And in fact, and then we divide both sides by sine of 45. So this is equal to 340 sine of 60 all over the sine of 45. Okay. So from here, we could plug this into our calculator, but let's go ahead and find the exact answer. Because we know what the sine of 60 is, and we know what the sine of 45 is. The sine of 60, so we have 340. The sine of 60 is the y value at 60 degrees. This is root 3 over 2. And the sine of 45, that's root 2 over 2. Okay? We know that dividing by a fraction is the same as multiplying by the reciprocal. So we have b is equal to, we have 340 root 3 over 2 times 2 over root 2. Our 2's cancel, and we're just left with 340 root 3 over root 2. Rationalizing, so we got to multiply by root 2 over root 2. We get 340 root 6 all over 2, which reduces to 340 divided by 2 is 170 root 6. Okay, and this is in miles. So this is the exact answer. If we were to plug this into our calculator and get a decimal approximation, we have 170 times the square root of 6. And oops, I didn't hit Control Enter. It's about 416.413 miles. All right. So yes, we could have just plugged this into our calculator right here, 340 sine of 60 over sine of 45, and gotten our answer. But I wanted to show this work as a demonstration that yes, when we have these nice angles here, we can do this without a calculator. We can do it algebraically here and get an exact answer, which is more precise than a decimal approximation. Okay? But from here, if you're plugging it into your calculator, that's totally okay. All right, so this has been the law of sines. In summary, the sine of an angle over the side length across from that angle, that ratio there, is going to be consistent for any corresponding side length and angle. Okay, and that's true for all corresponding side lengths and angles within a triangle. This is the law of sines. We use this for angle, angle, side, angle, and the ambiguous case, side, side, angle. Okay? We're going to get a lot of practice on this. If you have any questions, please put a comment below, send me an email. Otherwise, I will see you tomorrow in class. Goodbye, everybody.